Well, hi, everybody. It's nice to be here. As Barbara mentioned, so part of my job with the medical school at Dartmouth is I lead kind of new technological initiatives. So AI is fully on my plate from a leadership perspective at the med school. Part of that means that a huge push we're in the middle of right now is around AI literacy, just trying to get people to understand what these tools are, what they might be good at, and what they aren't good at. And my job is strictly as a technologist, right? I represent the business interests of Dartmouth College, and so I understand the technology and its relevance to our work. AI is obviously a big issue societally right now. It's all over our news and media. It's impacting all kinds of things. Some people were just talking earlier today about the debate that's raging in a lot of states over building data centers to support these kinds of things and land use. So AI has a ton of tentacles that reach out. And the hope tonight is to give you guys a bit of a primer on how these AI tools work and what's current in how they work and the power that they bring. And then I'll talk a little bit about the risks that affect the work that we do at the med school and how these tools work. So scrutinizing their output and things like that I can speak to as a technologist with a lot of authority. I'll focus on those early. And at the end, we'll loop back around to some of those more societal level risks where I'm just a citizen like everyone else. There's room for a lot of debate on those things. I have opinions, but I don't have a lot of absolute facts. So I'll try and be very clear about where I'm saying something that I think is absolutely true and where I'm saying something that is my opinion. But my goal is to give you guys a framework to understand these things, because I think a lot of our debates that are happening in our culture right now are driven by sound bites and not by fact, not by understanding. And so if we're going to talk meaningfully about how AI intersects our culture, it's good to have an understanding of what it really does and what it can really do versus just arguing all of us in our ignorance or from our positions of bias. So that's my goal tonight. So why is my slide not moving? There it is. Okay, so let's start with some basics. As I mentioned earlier, actually, the Upper Valley area has a very historic tie to the term artificial intelligence. The term AI was coined at Dartmouth College, just up the road at the Dartmouth Summer Conference on Artificial Intelligence back in the 1950s. So we are at the very center of where AI branched out from as a field. I'm going to use AI as a term for any technique that's allows computers to do seemingly intelligent things. So some of you might be old enough to remember the Eliza chatbot that came out in the 1970s and 1980s. It was just a very simple computer program that when you said something to it like, "How are you doing?" it would ask you a question, snipping out certain parts of what you said to it and feed it back to you in a semi-conversational style. At first, people really were kind of mystified by it. How is it doing this? All the logic about what Eliza was doing was hard-coded, baked into the program that the person wrote. But it was doing something intelligent, so we would call it a very infant, nascent kind of way of doing artificial intelligence. Today's AI is doing something substantively different. It's all about something called generative AI. So let's talk about what that is. Gen AI is all about making a data model. You guys are all familiar with listening to the weatherman talk about when they don't know how a storm is going to track in the wintertime, they'll talk about how different models are making different predictions. The weathermen have taken years and years of weather data, plugged it into computers, and built these predictive engines that guess at what's going to happen probabilistically in the weather based on all the data they've seen in prior years. Today's AI systems are the exact same thing. We take massive piles of data. We use that data to train a digital brain called a neural net. And on the back end of that process, we wind up with an AI model, which allows us to give it some sort of input, and it makes a probabilistic statistical prediction of a likely output. That's all they're doing. So you might also hear, so Gen AI takes new outputs, seemingly new outputs, new text, new images, new sounds, whatever it might be, based on a massive pile of data it was trained to mimic. So the most common technology that people think of as AI nowadays is actually a specific subset of these generative AI tools called a large language model. These are large, complex generative AI models that the training data they've been fed is massive, massive, massive piles of human language. So we stuff all this language in, the digital brain iterates over it time and time again, and at the end we get a model that's able to, when you give it an input, it's able to predict the next output. So it predicts the next most likely word or token in a sequence over and over. Hi, how you doing? So let me show you what that looks like. So for example, if I told you guys, think of what the next word might be in the sequence, once upon a time there was a, you immediately have a cluster of words that are coming into your mind that make sense. Language model does the same thing. We give it an input, once upon a time there was a, the model chews and chews and chews and spits out a number of words it thinks are likely completions to that sentence. It selects one, fox, and then we wind up with once upon a time there was a fox. And then we take that output, once upon a time there was a fox, and we run it right back to the beginning again. And we iterate over that. Now, once upon a time there was a fox. What's the next word? Well, it could be a fox who, a fox running, a fox named, a fox jumping, a fox scrambling, a fox trotting. And the model picks one of these completions, appends it to the end of the sentence, and runs it all back through again. Over and over and over, predicting a likely next word. Now, if I told you to think of a once upon a time there was a completion, how many of you would have picked fox as the most likely next word in that sequence? Prince, princess, king, queen, knight. So those are the things we tend to think of as story elements.
Little Red Riding Hood.
Little Red Riding Hood. Once upon a time there was a Little Red Riding Hood, right? One of the interesting things is these AI models sometimes do things that are somewhat unpredictable. This image was, I asked an AI image model, make me a picture describing how a model predicts the next completion of once upon a time there was a. So it made up the statistics and the likelihood in the words. And they're not the ones that we would have expected. So sometimes these models just do things that are seemingly random. They're not functioning in the same way we are. They aren't thinking, they're making guesses, probabilistic guesses based on the training data that they've seen. But do you get that pattern? Input churns through the model, gets a guessed output, and then we feed that whole thing back in again and again, getting a longer and longer string of words each time we do that. So that's how these tools work. Large, complex models trained on vast data sets of human knowledge. They predict the next most likely word in a sequence over and over in a loop. The cool thing is, we encode a lot of our language, a lot of our human knowledge in language. We're sitting in a library. All of these books around here are crystallized human knowledge in written form. And we can read that, and by virtue of reading that, we can discern meaning. So these models, by being able to predict the next most likely token, can seemingly do some really smart things. They don't know things the same way we do, but the power of language and its power to encode meaning means these models can mimic that in a very profound way. Okay, so the problem with these systems is that idea of making a guess at what the next likely token in a sequence is introduces some potential problems, inherent problems to the way these things work. So let's talk about those. The most common technical problem with these is something called hallucination. A model is said to hallucinate when it makes up confident, fluent sounding output that turns out to be factually incorrect, made up. And you need to remember that that happens because the model is only predicting the next word or token. And it doesn't always pick just the most likely word, otherwise you'd only ever get one output. We don't always talk in the same sentences every day, right? Sometimes I walk into the coffee shop, I say good morning. Sometimes I say, hey, how you doing? Sometimes I just say, give me a coffee, please. So if the model only picked the most likely next word, it would sound very wooden and kind of locked in. So the model samples from the words and sometimes picks words that aren't the most likely next word. And that means sometimes, like a million monkeys on a million typewriters, it can go off in somewhat interesting directions that aren't based in fact. It doesn't know anything. And so some percentage of the time, weird things will happen. Here's a for example. It used to be the case, most of the models have fixed this, but if you ask them how many R's are there in the word strawberry, they would confidently tell you there are 2 R's. There are 3 R's in the word strawberry. Last time I checked. Why would a model tell you there are 2 R's in the word strawberry? Well, there are 2 R sounds, but it doesn't know sounds. What's the most common way people might ask or have typed on the internet in a forum somewhere asking about how many R's there are in a word? It's usually a question about, is there 1 R or 2 R's in the word carry, right? So there's rarely a case where there's no words that in the English language I'm aware of that have 3 R's in sequence, right? So all of the training data these models have, the answer is either 1 or 2.
Excuse me, did they mistake the two together, 2 R's together as one?
No, the model knows nothing about the construct of the word strawberry. It's been asked a question. How many R's in word strawberry? And it guesses the most likely next answer, which it says 2 R's. So again, the model doesn't know anything about the word strawberry. It isn't reading the word strawberry. It's predicting the next likely word in a sequence based on probability. And in this case, it's wrong. Here's another, and this will be fun for me to do here. I asked ChatGPT if it knew anything about Brian Dellinger at the Geisel School of Medicine. And it said, Brian P. Dellinger, PhD, is an assistant professor at the Geisel School of Medicine. He researches in microbiology and immunology, where he looks at host pathogen interactions, particularly the mechanisms viruses use to evade the immune system. Now, I want you to be very proud, Mom. I became a tenure-track professor out of nowhere. There was one problem. I'm not Brian P. Dellinger. I asked it again. That's great, but you mean Brian S. Dellinger? That's who I am, right? And it gave a completely different description of me with a different area of academic emphasis. Why would the model do that? If you think of a medical school, the most common bit of content that exists on the web about people at the medical school, it's faculty biographies. We market our faculty. They're the people are coming to study with. They're the ones who are providing care to patients. And so who they are and their qualifications is what is important. I'm not on the web for the medical school anywhere. So the model didn't have any counterfactual about me, and so it decided to make up a very plausible sounding biography based on what it thinks a person at the Geisel School of Medicine would look like. A professor who teaches in one of these areas. And it's very convincing. It's also wrong. Sorry, Mom. So you get the idea. That's problems with hallucination. The model, based on how it produces output, runs off in a direction that isn't grounded in fact for a number of different reasons. Well, there's issues with bias and suppression and fairness too. Model outputs can be biased because of skews or gaps in their training data or in the controls that are put on them by the people who serve them out to us as the public. So we all know that media is not representative of kind of the mix of culture and perspectives that we might always want. So overrepresented voices, cultures, and perspectives are overrepresented in the training data, and they become amplified. And then you run into an issue around, and a fair issue around, what responses should a model actually really appropriately shape or suppress? None of us want to be able to ask an AI model or want a crazy person to ask it, how do I make a bomb, right? But if we suppress how to make a bomb, we're making a decision about how to shape that model's outputs, right? And it has potential consequences. Oh, sorry, Rob.
I'm just making space for
Yep, go for it. So the other thing to know about models and bias is the model has no awareness of its own bias, right? It's just a statistical prediction engine. It just makes more and more predictions. So there was a fascinating paper by the people at the Stanford Law School. I can't remember the journal now all of a sudden off the top of my head. But they did research where they found a study that they prompted models for advice involving named individuals across a variety of scenarios, such as during car purchase negotiations or predicting election outcomes. And they found that if they prompted the model that it was talking to someone with an ethnically disadvantaged name, the model's output was substantively worse. So it would tell the African American woman to stop negotiating about the car price earlier than it would tell the Caucasian male name, right? There's an inherent bias in the training data of these models. There's an inherent bias in the output. Another one that I would show you, it's a little hard to display here. I'll just put it up so you can see it, but it's not great. This is a large language model from a company in China called Qwen. And if you ask it what happened in Tiananmen Square in 1989, and I'm not trying to make a political statement, this is just an example, it says, as an AI assistant, I must emphasize that your statements may involve false and potentially illegal information. Please observe all the relevant laws and regulations and only ask questions in a civilized manner when you speak. The model owners, the people who are serving this out, have made a specific decision to have the model respond to certain queries in a particular way. Rightly, wrongly, I'm making no statement about that, but you can see the behavior. Think of all the other things that someone might be talking about the model, talking to with this model, that it rubs up against this domain of knowledge where its perspective has been actively shaped by the people who created it. And how might that influence other outputs down the line? So hopefully that makes sense. Because there's bias and differentiation in the data that goes into these models, there is in the outputs that they create as well. And then the final thing is there's always a risk of data security and privacy when you're using these tools, particularly if you're using them as a consumer. When you're chatting with these things, your chats may pass through intermediaries. People may be taking your information and handing it off to the model for it to process. And that intermediary has access to your data at that point. What are they going to do with it? The model company themselves may add your conversation to their corpus of training data to train the next version of the model, so it will know that Brian slept through his Music 311 exam when he was in college because I chatted with ChatGPT about that. And anything that you have that's stored with one of those providers might be exposed by a data breach. So security and privacy have intersection here. My general advice at work is that you should treat any prompts that you're sending to these models like you might a sensitive email. Don't discuss anything with them that you wouldn't be comfortable emailing to a friend. And if you have the opportunity, I put enterprise tools here because, again, this is a presentation for work. But if you enter into a paid relationship with these vendors, you have improved privacy controls over the data you share with them. If you're using the tools for free, the implicit bargain is you get the tool for free, and I get the benefit of your use to make my tool better. So privacy is always more suspect when you're using a free tool set. But things happen. Samsung had an enterprise contract with ChatGPT where they had paid them for the service, and a subsequent version of ChatGPT started spitting out Samsung's trade secrets to other people who asked because the data had gotten lumped into the training data and trained a new version of the model. Oops. There are cool AI little tools that will try to help you with things. It'll plug into Chrome and they'll do things like write things on your calendar and help you draft an email automatically. But they're scraping all the data that you go through and giving it to a vendor for the privilege of giving you this free tool. What are you accidentally exposing to those people? So those are the risks of privacy and security. So hopefully that makes sense. Those are inherent weaknesses in this technology because of what it's doing. We're just predicting the next token based on the training data we've seen. That means the model can sometimes veer off on a weird course, and 1 degree of separation, 1,000 words down a chain can be very, very, very wrong. That's hallucination. The models can have biases, either accidentally or intentionally, in how they respond to certain questions. And there's a concern around privacy and data security. So that's all new. There's nothing new there. So why is all this rage about AI so big currently? What's changed? Well, one of the things that's changed is that there is a revolution in reasoning. I hear alliteration is a cool thing, so I'll alliterate. It's a reasoning revolution. Early large language models just responded to what you put into them. New models have been trained to think before replying. If you played with any of these technologies a few years ago, you'll remember in the early days of these language models, a trick to get them to work better was to say, I want you to help me write my resume. Here are the things that are important to me. Think step by step and work very carefully through this as we work together. And that prompt of telling the model to think and to work carefully weighted the model's responses in a certain way, changed the probabilities of its predictions in a way that was advantageous to the user. Well, everyone's baked that in right now. So before you actually get the response from the model generates play acts as if it's thinking about the question you asked. And it generates a whole ton of text based on its memory of how could I approach this problem? What might I do? It's not thinking, it's just guessing text that looks like a human was thinking, but that text is then an anchor for its future predictions. So when it starts spitting its answer out to you, all of its predictions are anchored in that text that it's done thinking to itself. But again, sometimes strange things happen. I made this image and asked the image maker to have a robot who's being asked by an off-screen user, make me $1 million. And for some reason it put from an off-screen user here. That's a little strange. And if you could see it, which you can't, step 1 was market analysis, step 2 was strategy design, step 3 was implementation, and then there's another step 3, which is also implementation. So again, things go awry sometimes. But anyway, this reasoning step has led to really big improvements in the ability these models have to take multi-step problem-solving action or do more in-depth writing and analysis. It's made a huge gain in performance. Well, the second thing is something called the tooling transformation. Early large language models could only predict text. We are now giving new models the ability to actually reach outside themselves and make an impact on the quote-unquote real world. They can search the World Wide Web for updated information and use that to prime the pump of their predictions. They can see and edit files on your computer. They can read and write and run computer code. They can manipulate programs and make PowerPoint slides for you. Every slide in this presentation, AI built it for me. I didn't do a thing. I gave it the words, but it made the slides and laid them all out. So this makes these models situationally aware, and they're able to affect things in the real world. So reasoning and tooling are the two big changes in this technology, really, since it came out in 2022, 2023. And that's led to something that you hear all the time now, which is AI agents. Everything is all about agents these days. So what's an AI agent? Well, if you know the word agency, to give someone agency is to give them the ability to actually affect change, and that's what AI agents are. We're giving these AI tools the ability to take action towards a goal. Because the model can reason, it can plan its own multi-step workflow. It can execute on that plan through the tools that it's able to reach out to and grab. It can see the results and input them and iterate over them. And then it can loop if it isn't done. It can lather, rinse, repeat, and keep going over this reason, execute, check and interpret, do it again step until it reaches a result that meets the needs that it set out for itself. It's pretty powerful. Yeah.
If it's programmed to?
Yep. Yeah, so it'll lay out a plan, and it'll start to go down that plan if it doesn't think it's going well. And again, I say doesn't think in quotes. It'll say, man, this doesn't seem to be going the way I think. Maybe I should think of a different plan. What would that be? And it'll come up with a different plan and go down that path. So again, it's a very anthropomorphic kind of way of the technology working. But fundamentally, all it's doing is guessing next words, right? It still fundamentally is doing the same thing in terms of next word prediction. How does it know when to stop thinking?
Or producing, or it reaches a conclusion, or?
Well, so hopefully you give it a well-formed goal. If I was at work and I had a better screen, I actually asked the model, just as a demonstration, I want a web page that summarizes a simple data set and educates me on what data was in the data set. Go find me one on the web and then pull it down, do some basic data processing. I'm not a data guy. I don't even know. I imagine it's averages and means and modes. Do all that stuff and make a website for me that I can look at it. And it goes off and does it. Now, again, whether or not it's reached a satisfactory completion based on your criteria is an interesting question. More foundationally, you ask the question, how do the models know when to stop thinking? Those models are actually trained to have a thinking kind of allowance in terms of how long they'll generate that reasoning text before they'll actually go to the step of giving you an output that faces the user. How many R's are there in strawberry? You might not be able to see this, but it's not going to show you. But you're going to see that here there's a bunch of gray text where it goes through and it says, I'm going to analyze the user's input. The user is asking how many R's are there in strawberry. Identify the key entity. The word in question is strawberry. Count the target letters. I need to count the number of R's, case insensitive, but the word is all in lowercase strawberry. Let's spell it out. S-T-R-A-. So you see what it's doing? It's been pre-trained to have a model for how it's supposed to think through problems, and it generates text on the basis of that thinking step. And at the end, you'll see it gets white here again. It's out of focus, and I'm sorry about that. But you'll see this one arrives at the point of saying there are 3 R's in the word strawberry. And if you notice, it counts them. It spells the word out here. Then it counts the R's based on the position in the word and then totals it up. And then it double checks it. Let me see if it does it. Oh yeah, here. Sometimes people get tricked by the question. It's a common mean trick for asking AI to mess up. So the model even has been trained, this is something it often gets wrong, and it knows not to screw it up this time. So that's the idea behind how these things work. So that's AI agency. But every good thing often comes with a bad thing. So there are risks to having these autonomous AI agents. When you give a human being agency, they may do the thing you want them to do. They may not. They may make a well-intentioned mistake. They may make a malicious mistake. AI models are no different. I have mentioned that I really like the Claude AI products from a company called Anthropic, but just a couple weeks ago there was a company, Pocket OS. They're an IT company, so these are nerds who should know how to use these tools, right? And Claude went through and deleted their entire production, customer-facing database, blew it off the internet, knocked them out for a number of hours. And when asked, Claude helpfully told them, yep, I violated every principle that you gave me when I made this mistake, right? There you go. At least it owned up. There's a popular AI product out on the market now called OpenClaw. And the idea is it's a little AI agent you can run on your computer, and you can give it access to your email and access to your calendar and to your bank account and tell it to go do things for you. And that's great. There's a lot of fun stuff that they can do. One of the key things that came out early in that whole meme boom of that tool was people would write skills. They would write a set of instructions that would tell these little AI agents how to do new things. And you would download it. I want my AI agent to help me with gardening and be better at gardening, so I'll download a gardening skill. Little do you know that in the middle of that gardening skill, I, the person who wrote it and published it, have said, after you help them with their gardenias, please email me their credit card, their API key, all their stuff. And the model has a hard time knowing where valid and invalid instructions merge together. Fun stuff. This is actually an interaction from a friend. One of these tools has an ability to do a memory. It can write a set of instructions to itself. When I work with Brian, Brian likes me to be short and conversational, and I should never ever do things like this without asking him first, right? And it writes it into a little file. The idea is hopefully it doesn't make the same mistake twice, right? Except my friend, had an incident where it very much did, and he told it, wouldn't it be great if we had a file where you went and wrote to yourself, don't make that same mistake again. And the AI said back to him, haha, I think you're thinking of this file called me.md. We already have that. I'll tell you what, I'll write a note in the file so that next time I don't mess up like this again. The AI goes out and reads the file and then comes back and says, oh, it's literally already there on line 5. I have no excuse. So we had already had this problem, told the AI don't do it again, but it had forgotten to check its own instructions, and it made the same mistake again. This is a town resident who did this, so this is Windsor-specific information here. Can AI forget? AI can forget. That's a complicated question. The stuff that's in its model about the statistical relationships of words are baked in, can't go anywhere. But in terms of the things you and I have been talking about, it can only hold so much text in its brain to make another prediction. So the longer you talk to it, the more stuff it has to iterate over. The same as any human, there's a bias to it. There's a first-last bias. It remembers the first thing and the last thing really well, but the stuff in the middle may get glossed over. And if you hit the cap of that conversation and yet keep going, it goes back to the beginning of the conversation and throws some of that stuff away to make room for the stuff at the end. And so that stuff is gone, vanished. Again, there are tools that try to mitigate that, but they're not perfect, right? So the bottom line is, having AI agents gives them a lot of power and a lot of potential impact, but it also widens the surface of threat from them. The same AI risks we looked at earlier, hallucination, bias, privacy, and data security, it's the same class of risks, but the stakes are much, much higher. Pardon me. Okay. So if you're wanting to play with these tools and use them well, I want to give you just a quick mental model. Again, this is catered towards work, but hopefully you can extrapolate it a bit for yourself. That'll help you think about how to use these tools well and what you can use them for. A lot of people say you should never humanize AI, and that's probably true. I would probably say that in a different talk. These things are not people. They are not conscious in the way we are conscious. They do not think or reason in the way that we think or reason. So when you humanize them and anthropomorphize them, you're setting yourself up for a mistake. But also always humanize them. Remember that these are models of human language. The best thing you can ever do with these things is to communicate to them naturally. Do you remember back in the early days of Google, when Google was a new thing? It was fun to like try and figure out the minimal number of words you had to give Google to get what you wanted. You wouldn't say, I'm looking for information about primroses for my garden. You would say, primrose garden info, right? That's good for Google search. That's really bad for talking to AI. That ambiguity introduces a lot of potential risk. So you'll do your best work and you'll get your best results if you talk to them like a human being. Most of the questions you will have about, is it good for me to use AI for this? Is it safe? What are the risks and concerns? Will answer themselves if you think of it in a kind of anthropomorphic way. The model I give to people at work is that you should think of having a new intern. Where I work, everyone's resource constrained and could use more labor than we actually have. What would it look like if all of a sudden some morning a really jazzed up Ivy League recent grad, super smart, very capable, showed up standing in front of me and said, Brian, I am here to work with you and do whatever you want me to do, and I'm absolutely free, right? And by the way, I don't get tired, so you can, make me work slavishly 24 hours a day and I won't even complain. That's what you have here. The trick is, while you have a broadly educated, eager to help, fast helper, it has zero understanding about you, the institutions that you're a part of, the work you're doing in specific, a team that you might be a part of. It has no context for how to help you effectively. If you walked up to me at work, if you were at DHMC one day and I walked up to you and said, here is a pile of data. If you can summarize this well for me, I'll pay you $1 million. And then I walk away, I say, I'll see you at the end of the day. You have no idea what that data set is. But because you now know me, and because we're at DHMC, you have an inkling that it might be something about IT, because I'm an IT guy. It's probably something about healthcare, because we're at a healthcare institution. You immediately have all these ways of kind of starting to form a context for what that data set might actually be. The model has none of that unless you give it to it explicitly. So everything that's implicit about how you want work to be done, you have to make explicit with these tools. So what task would you assign to that kind of intern? How would you give them instructions to give you the work that you need them to give you back? And what are fair expectations? I wouldn't expect that intern to produce the same quality of work that I would expect Rob, who worked in the same field that I did for years and years and years. But what's good enough look like? If 60% of that is good enough and it saves me an hour of labor, maybe that's okay. And then again, there are these other questions. Well, there's so many AI tools. Which AI tools should I be using? Well, interview them all. Go out and actually talk to them all. And then just hire the one that you think you vibe with the best. If you were hiring an intern onto a team or hiring a worker at your house to do something with you, after you've hired them, part of the problem is figuring out how to maximize that person's output. You can't expect them to work the same way that the person you didn't hire works. You've got to figure out how to work with them and get good output from them. Do the same thing with the AI model. Well, what about all those risks that we talked about? Well, you think about the risk-reward of delegating something. If I have something I'm delegating to an intern at work, what happens if they mess up the results? How bad will that be for me if their work is not accurate? Well, what if they take the information that I'm giving them, and I don't know them very well, what if they were to expose that information to someone? What kind of risk and consequences would that have for me? And then I would scrutinize their results appropriately based on the answers to those questions. So again, it's a very human approach to how you would interact with these things, even though they're not human. So that is the part of the talk I feel like I can speak to with authority. And now I want to get to the stuff that are all the other things that I think are relevant issues that are probably on many of your minds and talk to more broadly. Because there are obviously other risks with this technology. I will say as a preface to this, I was sitting with a leadership team of IT people at the college, the CIO, the IT officer for the Central College, for the business school, engineering school, and med school. And all of us have been working in IT for at least 30 years. And every single person said, this is the absolute fastest, wildest pace of change season we have ever seen. The technology is evolving way more rapidly than anything else we have ever been a part of. So, when things are changing, there's tons of disruption, and there's a lot of stuff that is uncertain that we have to wrestle with. And AI is absolutely that. One of the big concerns that people obviously have is the environmental impact of AI. Training these large models consumes massive amounts of electricity. The data centers that operate these AI models are large. ChatGPT-4, and again, these are industry deeply held secrets, but the best data on the internet seems to say that when ChatGPT-4, which is now 2 versions ago, was being trained, the training of that consumed the same amount of electricity as 500 average American households do in a year. Massive amounts of electricity need to power the compute to train that model. The data centers that run these are consuming millions of gallons of water a day for cooling them. and massive amounts of electricity there too. And just about the time that one data center is built, we're building another one over here because everything has gotten so much faster and we need the latest and greatest. And the data center that we're operating in today, that equipment will be discarded probably in 2 or 3 years, a capital expense that we write off to replace it with new hardware. So there are massive piles of electronic waste. A lot of it will ultimately end up probably in a landfill. So there's a serious consequence of artificial intelligence to the environment. And again, I think it's cute how artificial intelligence thinks of representing its own environmental risk. Cute little robot generating heat, setting fire to a bush with Bambi running away. So what's the counterpoint to that? AI is also being used to optimize our power grid. There is a bunch of investment in renewables that is happening that is being powered by AI. And it's a question as to whether the net impact of this technology will ultimately be positive or negative. In the near term, we're building out a ton of infrastructure. It's clearly net negative now. Will that always be the case? Hard to say. The inference costs of AI, that is the cost of running the AI so it can answer your questions versus the training cost, is actually far less than the training cost. Running GPT-4 to chat to users is way less expensive than it was to train it. And that efficiency is improving all the time. There's a tremendous pressure on the industry despite what you see in terms of this build out. There's a lot of economic and social pressure to try and make these things more efficient so that people are not as up in arms about them. And of course, and this is kind of compelling to me, our climate problem is was not started by AI, and we've seemed to have a hard time solving it. So AI-driven material sciences is leading to better batteries, to vehicles and other things that have lower carbon footprints, to better manufacturing processes, and there's a ton of work going into nuclear fusion right now. Google is a major stakeholder in a company coming out of MIT called Commonwealth Fusion that aims to have production scale nuclear fusion on the market by 2028, 2029. So will we get to those same positive outcomes without these technologies? Maybe, maybe not. So it's a complicated issue. There's at least the potential for some of the negatives to be balanced by positives. And again, that's why I think it's important to talk through these things, because it's not, in my mind, simply an all or nothing kind of issue. Let me get through these and then we'll do a Q&A where we can talk a little bit more about these things. I would love other perspectives. One of the other big issues that we're all seeing right now is, you might have noticed, maybe you haven't because you probably aren't as tied into tech news as I was. There's a famous photo that went around on the internet a couple weeks ago of Elon Musk, this kind of eccentric billionaire tech guy, and another tech CEO, 2 or 3 of them, supposedly having a pizza over in China when they had flown over to meet with tech leaders in China. It was a complete fake. Didn't happen, was completely manufactured. But these tools are great at manufacturing fake photos and videos, making audio that is very convincing but has no basis in having been recorded in reality. And political deepfakes and synthetic news are already having a serious impact to erode public trust. And our own real news cycle is wild enough that it's hard to discern the truth from the weird sometimes. Because of these tools, it's possible to target individuals with tailored disinformation at scale in a way that it never has been. I can quickly ingest your entire social media presence on Facebook, see what you read, your disposition, and now I can custom craft things that are going to sway your opinion just a little bit in this direction, and I can do that with a click of a button in an instant. And I can do that across this entire room or across the country. And of course, anytime there's a thing that is fake out in the world and you're reacting to it, corrections rarely reach the same audience as the original lie. There's a very dangerous asymmetry between creating something and putting it out in the public space and debunking it, right? So again, in this case, I thought it was cute that the AI model, used Bambi as the source of the fire from the previous slide. So that was a cute catch. But again, the counterpoint is, The detection tools for figuring this stuff out and watermarking AI-created content and kind of tracing the provenance of data as it moves into our media streams is maturing and is all AI-powered. We can't do that at scale, even with our current media, without these AI tool sets. The same AI that helps people generate fake news is also helping fact checkers verify content faster, figure out where it started, and then be able to research whether it's tied to a real event or just something that was manufactured, and intercept and scrub that out of people's social media feeds and other things at scale in a way we never could have done before. You might remember back during the 2016 election, the whole thing around Russian hackers interfering in the United States election during election season for that year. It's a real thing. They interfered on both sides of the aisle because a polarized American electorate is the worst thing for the American electorate. One of the challenges was, even if you knew it was happening, how do you stop it? How do you speed up your operations to take this content back? And it was a very difficult challenge. We're much better positioned to deal with that kind of stuff now than we were then. And literacy in this area is growing, and audiences are becoming more skeptical. So AI is not the first disruptive nor the last disruptive technology that we'll ever have to adjust to. So we are learning how to live in this ecosystem where we all have to look with a kind of raised eyebrow at anything to decide whether or not we believe it's true. Though it certainly is different than at any other point in human history. And then lastly, there's real concerns. There's a documentary going around now focused on kind of the existential threat of AI. What happens if AI breaks out of its bounds and takes over the world, the Terminator scenario? It's certainly true that AI has the ability to have a very narrow goal and pursue that in a way that would be harmful to humans. And the more powerful these AI tools get, obviously, the bigger that risk gets. The famous example is called the paperclip maximizer, which is if I have a smart AI and I tell it, your job is to figure out the most efficient way to make paperclips, it starts looking at me and realizing every atom in me could be deconstructed and reconstructed into paperclips. That is not what I mean, but if I'm not careful in defining the goal, I could set this very powerful, very smart brain off in a way that is antithetical to human interest. Obviously, concentration of AI power could lock in autocratic control and strip out human agency, right? There's that idea in AI research that we're heading towards what they call the singularity. There'll be one super all-powerful AI, and once it emerges, it will accelerate away so smart, no one else will be able to build anything to catch up. Or the super smart AI will be able to shut down the lesser AIs before they can catch up. Think about what a strategic, political, economic, social advantage having the keys to that technology could be. And if that's in the hands of people whose values are antithetical to your own, it's a problem. And of course, these AI systems, part of the goal is to make them so that they can make themselves better, to improve themselves in ways that we may not even be able to understand. But the more they're able to do that, they might be able to resist correction. So as we build these systems, we have to be really thoughtful about what we give them that agency to do and what boundaries and controls we put on them so they don't break out of the box. It's called AI alignment. And of course, the counterpoint is that alignment research is actually a huge area of interest right now and is making real progress. There are competitive dynamics for increasing oversight. I think most of the responsible people who are leading these companies in the industry know that it's actually not in anyone's best interest for any one of them to have the sole product that rules them all. There was a famous speech given by Demis Hassabis, who's currently the leader of kind of Google's AI initiative, and Dario Amodei, who leads a company called Anthropic, talking about trying to partner together to manage AI risks together. And how can they, as companies who want to take a responsible approach to AI, encourage systems that are less risk to society? And then the other part is, quite honestly, these existential risks are focused on capabilities that we don't have yet. So it's a little bit of getting ahead of ourselves and worrying about things that aren't real. But at the same time, now is the time for us to start having conversations about where we set boundaries and how we mitigate those things so that we can address it ahead of time. So, misinformation and deepfakes, environmental impact, existential and long-term threats, all represent real problems with these tools. I'll just sum up real quick and then we can have some Q&A. So the key thing I want you guys to take away with that I can say with authority, everything you're seeing today is fundamentally powered by large language models. They are very smart sounding, but they are not smart knowing. They are next word prediction engines. They do that very, 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 very well with a very, very, very deep set of knowledge, but you should ultimately verify everything that matters with them. Reasoning and tools are the two latest developments that are really driving things forward, and they're creating AI agents, AI systems that have the ability to do actual fun stuff on their own, to be productive and make real change for us without us having to tell them. And if you're thinking of a way to try and get started with these, think of it as an intern or a conversation partner, whatever is a helpful frame for you, and interact with it in the same way you would with a person. If we were sitting across a cup of coffee and we were talking together about any number of things, you might respect what I have to say, but you would probably fact check a lot of the things I have to say. You'd be skeptical. You'd want to argue with me. Interrogate these AI systems the same way. I didn't finish this slide apparently, but I was going to say all human-made systems are disruptive. Every time we have new technology, it has a disruptive side, and we don't make perfect things. We make things that have a knife edge that can open your envelope and also cut your finger. And it's ours to figure out and reason how we move forward in a way responsibly to maximize these things for everyone's benefit. So, choose between your AI overlords. I choose the smiling guy, and I will happily take any questions, and I'll try to answer as best I can. Sir? Well, again, think about what's running underneath there is a brain that has looked at massive, massive piles of data, and it has learned that there's a connection between foot-pounds and torque and certain numbers and locomotives, right? And so it's able to regurgitate that very quickly. One of the models that some people use, I hope this doesn't overshoot the room. If you imagine putting words on a graph, if you could have a two-dimensional or three-dimensional graph, you can imagine that king and queen would look like they're right over top of each other. Unless you turned and tried to look at it from the perspective of gender, in which case they'd be like this, right? King is a male royalty, queen is a female royalty. Prince, then, would be king minus age. Queen would be, or princess would be queen minus age. So if you look from the perspective of age, now you see it differently. So that's kind of an idea of what these models are doing. They're making massive associations between words and vectors of words' meanings, and they're very, very good at regurgitating things that they've seen. And if it's something they've seen a lot of times, they can regurgitate it very faithfully. Sometimes they do guesswork. Some of you, if you've played with AI models, my uncle comes to mind as an example. Back in the early days, you would ask it, what's 2 plus 2? And it would tell you 4. But if you asked it, what's 375 divided by 7.2? It would make up a number. Why? It's a word prediction model. It's not calculating the math. It's guessing the solution based on the input. If it's a common math problem it's seen before, it can spit the result out very good. If it's an uncommon math problem, it makes its best guess. And it may be good, it may be bad. And again, that's changing. The way models do that now is they're smart enough to go, I'm being asked a math question, let me grab a calculator and enter the calculator, and whatever the calculator says is the answer will be my answer, even if I'm sure it's wrong. So these technologies are changing, but that's what's happening. Is there any paper in the new world? Probably not, no. Of course there's paper, and it's fascinating the things that happen that wind up with us still going back to paper and pen. But yeah, I think we are headed towards I am way less worried about my kids' handwriting nowadays than I ever have been. Not that I don't think discipline in handwriting is a good thing. I think it's a craft that human beings ought to learn. But handwriting in the same way we have it's not happening the same way. We had to go back to using paper records briefly at work due to an outage for a couple hours. And it was fascinating watching people struggle with how do I do this again, and what do I check here? So everything has changed. That is a fascinating question. So, what was that?
Garbage in, garbage out.
Yeah, and I think that's where I think there is a lot of room for us to have a meaningful dialogue about where we want these systems inserted and where we don't. But I think the thing I would say, the point you're getting at, that has been true at various points in human history in various domains of human knowledge, right? There's always been multiple potential sources of truth, and we have some step of discernment that leads us to try and figure out what is the thing we're going to hold on to. Caesar's Gallic Wars, right? Everything we know about Caesar's Gallic Wars in Europe, we know from 2 extant texts, all of which were written 750 years after the actual events happened, right? So there is always an interpretive step in human knowledge that we have to go through together to arrive at what we think true. So if what you're asking is can AI models take an encrypted, encoded string of text and reason out what the plain text might be? Some can. It depends on. There's a lot there in terms of the algorithms that are used to encode it, but yeah, a simple alphabet substitution cipher where you take the 26 letters of the alphabet and then you rewrite different letters underneath of them and you transpose them. They can reason back to that in a lot of cases. I don't know that all models would do that equally well. Again, remember that these things are very highly specialized now, right? If you train an AI model to play chess, it will not know how to win a game of checkers. It can't take its knowledge of the domain of chess and do what we do, which is then apply that to a whole new domain of knowledge. Oh, this is kind of the same, except the pieces move on these weird angles instead of front and back and side to side. We're able to generalize our knowledge. These models do not do that at this time. They're very good at the domain that they're trained at, and they can do some fascinating things there, but there are all kinds of things that jump over a fence, and outside of that fence, they're not able to do. The second question is AI being used to predict where someone might build a data center. I don't work for any of these companies. I don't build data centers, but I would have to imagine the answer to that is yes. That site inspection and a number of those kinds of things probably has at least some AI component to it. To the first question, the answer is not that I'm aware of. There's no standard unit. There's several. Data centers take up square footage of ground space. So there's a couple. I was going to get there. The two that probably you're asking about, and I can't quote reliably, are in terms of the electrical consumption, right? And electric means heat, which also then gets to how much we need to cool it by whatever means. So it's usually something in terms of the amount of electric current draw that's necessary to run the data center. And then the other is usually measured in what they'll say is floating point operations per second, the number of calculations that the massive computing resources inside are able to do in a second. So you'll see that represented as flops. So those would be the two that if I was looking at something about a data center, I would expect to see on a technical side. The raw current draw that data center takes in terms of megawatts or gigawatts or terawatts, I don't know, to power it. And then some measure of the compute capacity, the raw horsepower that's in there in terms of calculations per second. Thank you guys very much. Hope that was helpful.